Okay, next one, example 19. Two objects of masses M1 10 kg and M2 15 kg are connected by a light string which passes over a smooth pulley as shown in figure. Calculate the acceleration of the object of mass 10 kg and the tension in the string. So we are given two objects here with mass 10 kg and 15 kg. And then as you can see in the figure here, we are given a direction. So this is actually a direction of acceleration. So we need to follow the direction given. Okay, but if we are not given the direction, okay, we can identify, okay, by looking at the mass. Okay, so kalau kamu tengok dekat sini kan, mass tu is larger than mass 1. Okay, mass 2 15 kg, mass 1 10 kg. So mass 2 is larger than mass 1. So if we are to put them in a pulley, we know that mass 2 yang akan bergerak ke bawah. Okay, dia akan tarik mass 1 sebab dia lebih berat daripada mass 1. That's why kita punya motion adalah macam ni. Ni akan jadi ke atas, ni akan bergerak ke bawah sebab this one lebih berat daripada this one. Okay, so if we are not given the direction, so kamu kena identify macam tu lah by logic. Okay, but if you are given the direction, so you need to follow. Okay, so first thing to do, identify the forces on each object. Okay, so macam biasa kita akan ada weight force going downward and then tension going upward. Okay, going away from the object. So untuk mass 1 pun sama. And then tension away from the object. Okay, you need to remember always to label the W sebab dia tidak akan sama. Each object will have different weight force sebab mass yang berbeza. So kamu kena biasakan untuk label sebab nanti kamu akan confuse, kamu akan assume dia adalah value yang sama padahal dia bukan value yang sama. Okay, so tension here will be the same value sebab dia adalah the same string. Okay, so now let's draw the FBD. So untuk M1 FBD, first we know that there is weight going downward and then tension going upward. So acceleration ke atas. So untuk FBD, kalau tidak lukis X and Y axis pun tidak apa sebab X and Y axis ni kita lukis sebagai guidance. Okay, usually kita lukis apabila kita ada angle, tetapi for now sebab dia sangat simple, kita hanya ada dua forces dan hanya ada satu component which is the component Y sahaja. So you don't need to draw the axis here. Okay, so next one M2, benda yang sama juga. Okay, tetapi acceleration kali ni adalah ke bawah untuk M2. Okay, so kita akan keluarkan equation for each of the FBD. So since kita hanya ada satu component, we don't need to draw a table for this one. So kita tengok yang first one first, M1 M1A. Okay, so follow direction of A will be positive, opposite will be negative. So T will be positive, W will be negative. So kamu susun akan jadi M1A plus W1. So this will be the first equation. And then second one M2A, di mana W2 follow A, so W2 yang akan jadi positif, KT akan jadi negatif. So akan dapat T is equal to W2 minus M2A. So second equation, okay, boleh solve macam biasa. M1A, okay, since this one kita tahu W adalah sama dengan mg kan. So terus masukkan dalam equation di sini, m1a plus m1g equal to m2g minus m2a. So this one daripada ni, and then this one pula daripada sini. Okay, so since kita mau adalah value for a, so susun dia. Okay, this one, and then kamu akan dapat, kamu akan factorkan lah. Okay, factorkan m1 plus m2 equal to m2 minus m1 times with g. So a will be equal to m to m1 divided by m1 plus m2. Okay, dan lepas tu barulah kita masukkan value, di mana m2 adalah sama dengan 15. Is it 15? Yes, it's 15. Then g is the gravity. Okay, divided by 15 plus 10. Okay, so you will get the acceleration is equal to 1.962 meter per second squared. Okay, so next one, we need to find the value for tension. So gunakan any of the equation. Okay, T is equal to M to G minus M to A. So kita gunakan equation yang kedua ni. So kamu boleh dapat 15 9.81, masukkan value masukkan value A yang tadi 19.6, sorry, it's not 19, 1.962. So tension will be equal to 117.72 Newton. Okay, next one, example 20. Figure shows a block of mass M1 6 kg on a horizontal surface with coefficient of kinetic friction mu k 0.22. Is connected by a string through a pulley to another block of mass M2 3 kg. The system is released from rest. Okay, draw the forces acting on the blocks when they are in motion. Calculate the acceleration of the blocks and calculate the tension in the string. So we are given M1 and M2 here. Okay, given the mass 6 kg and also 3 kg. And then the surface here, okay, has a kinetic friction. Okay, coefficient of kinetic friction given 0.22. And then the system is released from rest. So when it is released, obviously kita tahu pergerakan dia akan ke bawah lah. So M2 ni dia akan tarik M1. Okay, even though M2 is less than M1, okay, walaupun mass M2 is less than M1, tetapi sebabkan mass M2 ni dia seorang saja yang tergantung over the pulley, so obviously kita tahu dia akan tarik juga M1. So akan ada motion going downward. Okay, so motion will be going to here and then going to here. Okay, so first of all, let's identify the forces acting on each block. Okay, so now untuk M1 kita tahu weight going downward, and then it is on the surface, so there will be normal. There will be also tension and then friction. So friction opposite direction from the motion. Okay, motion ke kanan, so friction opposite. And then second one, here, weight 2, and then tension. Okay, hanya ada dua sahaja untuk M2. Okay, so now let's draw the FBD. Okay, draw for M1 dahulu. Okay, ke kanan adalah T, ke bawah is W1, to the left will be Fk, and then upwards will be the normal force. So M2 kita hanya ada 2 going downward, and then the tension going upward. So the acceleration, this one going to the right, untuk M2 going downward. Okay, so next one, so this one adalah soalan A, di mana we need to draw the forces. So maksud draw the forces here adalah lukis FBD. Okay, apabila lukis FBD, always include the area and then the label. Okay, label mesti betul. Untuk M1 dekat sini adalah W1. Okay, kalau tulis W saja, label akan jadi salah. Mesti ada label 1. Okay, next one we want to calculate the acceleration of the block. So acceleration akan sama because it is, okay, they are moving together. Okay, these two are moving together since they are connected with a string. So acceleration akan sama. So as you can see here, acceleration satu di Y component, satu lagi di X component. Okay, so bermaksud kita kena tengok kedua-dua komponen dekat sini. So you need to be careful here. Okay, let's draw a table for M1. Okay, kita draw a table for M1 first. Okay, so for M1 we have 4 forces. We have N, T, Fk, and W1. So this one X component, this one Y component. Okay, di mana N kita hanya ada di Y component. N is not given, T is not given as well. So T going to the left. T same direction as A, so positive. This one 0. This one Fk, opposite direction, it will be negative. Okay, so before that Fk kita tahu adalah negative. Fk adalah mu kn. So kita sudah dibagi the value for mu k, which is 0.22. So masukkan 0.22 n. This one will be 0. This one kosong. W1 akan jadi negatif M1. M1 sama dengan 6 dan G. Okay, so kita punya acceleration adalah di X component. So Y component akan jadi kosong. Okay, X akan jadi sama dengan MA. So now keluarkan equation ni. Okay, kita keluarkan satu persatu. M1 adalah 6 and then A. Okay, so this is the first equation. And then second equation adalah Y component, di mana N minus W, which is 6 times. So kamu boleh dapatkan value for N here actually, di mana N will be equal to 58.86 Newton. Actually boleh sudahlah terus masukkan daripada ni ke sini. So 6A tambah 0.2258.86. So kita akan dapat 6A tambah 12.949. So this is actually the first equation. Okay, so that one is for M1. So now M2. Okay, M2, since kita hanya ada satu komponen, you don't need to draw the table. So just keluarkan, di mana T will be negative since it is opposite direction as A, and then M2G sama dengan M2A. So T will be equal to M2G minus M2A. So this one boleh masukkan. So kita akan dapat T is equal to 29.43 minus M2 tadi adalah sama dengan 3A. So this is the second equation. So kita boleh samakan equation this one and this one. Okay, kita akan samakan. Okay, supaya kita boleh solve. Okay, and then kita akan dapat 1 point. Okay, acceleration is equal to 1.83 meter per second squared. So now sudah dapat acceleration, so you can find the value for the tension. So use any equation. Kita gunakan equation pertama lah. Equation yang ni. So kita akan dapat T is equal to 6A plus 12.949. So akan dapat tension will be equal to 23.93 Newton.